Alright guys, welcome back, and today we are going to be reviewing again some things that we probably should have gone over in Integrated Math 1, but it could have been something a while ago, and especially with how last semester ended, I think it's good to just hit it again, kind of unrelated to what we're doing, but I just see gaps in knowledge that I think we really need to fill in order to understand what we are doing currently and to do things in the future. So we're kind of just backtracking for like a second. Don't forget about all the parabolas and the factoring and all that stuff we did. Keep that stuff in your head, right? Because we're going to come back to that stuff. But for now, we're just kind of hitting a review a little bit. So for this warm-up, this think/warm-up, I have, what does 3 squared mean? And well, 3 squared really means, so 3 squared really means 3 times itself, right? That's what squared means. Something times itself, which 3 times 3 is going to be 9. I know that most of us know this, and I think all of us actually know this, but I think it's just a matter of breaking bad habits. A lot of times when we see 3 squared, we want to just do 3 times 2, which is 6, but we need to remember that it's 3 times 3, which is 9. And so what does x squared mean? Well, it means the same thing, right? It means x times x, right? Something times itself. That's what squared means. So x to the 5th, what does x to the 5th mean? Well, that's going to mean x times x times x times x times x, right? To the power just means times itself that many times. So x times itself 5 times. And now what does x to the 5th times x cubed mean? So we're getting a little crazy here. So x to the 5th times x cubed, that's my definition of crazy, so you know how exciting my life is. X times x times x times x times x, this is x to the 5th, right? That's x to the 5th. And then we have times, and then x cubed is x times x times x. And that's x cubed, which notice altogether that's x to the 8th. And we might see a pattern there that 5 plus 3 is 8. And that pattern is absolutely going to persist later on, and that's our first rule for our powers, right? So if we have a to the n times a to the m, the new exponent is a to the n plus m. And that's, a general term. And what this is saying is if you have 2 things multiplied together with the same base, we call this the base, 2 things multiplied together with the same base, then you're going to add their exponents. So, for example, if we have x to the 4th times x cubed, that's going to be x to the 4th is x times x times x times x, 4 x's, and x cubed is x times x times x. So all of that multiplied together, I think when we write it all the way out, we can kind of see why we add these exponents, right? Because really, all these things multiplied together is x to the 7th. Or you could just do 4 plus 3. That's how you think about it. And then they need to be the same base. Otherwise, and in other words, what that means is these both need to be x's, right? If this was x and this was y, you obviously couldn't combine these. So let's get into a couple examples of these. We have v to the 4th times v, and for that, we can think that v is really v to the 1st if it helps you. And you can kind of think of it 4 ways. You can, if it helps you write it out, we have v times v times v times v. That's v to the 4th, right? And then our last one there would be v to the 1st, if color code it there with red, right? And then you can count all those and you could say, well, that's v to the 5th. Or you could say, well, I know that when I'm multiplying 2 things with the same base, I'm adding the exponents. So really, it's going to be v to the 4, and then plus that invisible exponent was an invisible 1, which is v to the 5th, right? And then once we should get comfortable with these pretty fast, what I like to think is that if we have 4 v's and I'm multiplying another v, then we're going to end up multiplying v to the 5th. And so you might not need to do this 4 plus 1 work. Hopefully, that's where we will get Now here, we have some coefficients involved, right? But remember, you can multiply things in any order, right? 3 times 4 is the same thing as 4 times 3. It doesn't matter the order you multiply things in. So I personally am going to multiply those coefficients first. I'm just going to rearrange it, right? And then we're going to have times t cubed times t cubed. So all I did was rearrange this. I put the -4 and the 2 together in front because you can all this is multiplication, right? There's multiplication there, and there, and there. So it's all multiplication, and I just rearranged it, right? So in other words, you could always just do the numbers first. 2 times -4 is -8. And then t cubed times t cubed, that's going to be t to the 3 plus 3, right? We're multiplying with the same base, so we're adding these exponents, or -8t to the 6th. And now for this one down here, same kind of deal, right? We can multiply in any order, but I'm going to stick these x's together, and I'm going to actually do this one faster than the others, right? So first I'm just going to do the numbers. 9 times 3 is going to be 27. And now notice we have x, which is really x to the first, times x squared. That's going to leave us, if we add those exponents, or if I have 1x here and 2x here, that's going to leave us with x to the third. Right? Just because there's more than one variable, don't freak out. Now we have the y's. We're going to end up having y cubed times y squared, which together that's going to be 5y's, or y to the 5th. Right? So don't freak out, just match everything, right? That's what you can do with these. You can do the number multiplication first, then the x's, then the y's. Just keep it all in check, right? Like, don't start multiplying x's and y's together to get some crazy exponents. Just keep them together. So our second rule is that if we have a to the n, all to, like, in parentheses to the m, then you multiply. So if you have an exponent, if you have an exponent of an exponent, you multiply the exponents. And you might be thinking, well, that's kind of weird, but I think once we look at an example, we'll see it, right? So if we had x to the third, that whole thing to the fourth, what does to the fourth mean? That means take this thing and multiply it by itself 4 times. So let's do that. X to the third times x to the third times x to the third times x to the third. And I think that we could see from our previous rule that's going to be 3 plus 3 plus 3 plus 3. And another way to write 3 plus 3 plus 3 plus 3 is 3 times 4. 3 4 times, right? So that'll get us 12, right? And if we, sure enough, if we have these 3 plus 3 is 6, plus 3 is 9, plus another 3 is 12. We'll get there. And then down here is another good one to notice, right? So 3x squared all together cubed, what that means is 3x squared times itself 3 times, right? So we actually get, when this 3 is bundled in here, we're going to get a 3 times 3 times 3, which is really 3 cubed. And then an x squared times x squared times x squared, which is x squared cubed, right? But if you think about it like this, you can kind of skip this step if you want, but I just have both there so that you can think of it however you like. But I just like to think of it this way. I'm going to have 3 times 3 times 3, which is 27, and then x squared times x squared times x squared, which is x to the 6th. And so let's do a couple examples of these. We have negative 10x to the 4th, all of that to the 3rd. So what that really means is negative 10x to the 4th times negative 10x to the 4th again times negative 10x to the 4th. So this is one way to think about it, right? Negative 10 times negative 10 is going to be positive 100 times negative 10 is going to be negative 1,000. And then x to the 4th times x to the 4th times x to the 4th, right? There's multiplication in between all these. We're going to add those because now we're multiplying with the same base, is going to be 4, 8, and 12, right? And if we were to follow our rule here, right, we could follow our rule and do the same thing. We could say, well, that means that we're going to have negative 10 to the 3rd times, and then we have x to the 4th x to the fourth to the third is going to be the 4 times 3, right? Negative 10 to the third is going to be negative 1,000. And 4 times 3 is to the 12. So again, this 10 gets wrapped up in this cubed, but then you can just multiply these two exponents. 4 times 3 is 12. But if you like to write it out and think about it that way, that works too. And here, just another one, squared just means times itself. So we're going to have negative 2q times negative 2q times itself once, right? Negative 2 times negative 2 is going to be positive 4. Q times q, these are invisible ones. It's going to be q squared. Another way you can think about it, you're going to have negative 2 squared, which is positive 4. And then q to the first times 2 is just going to be 2. So one last rule, and it's when we divide these things. If we have a to the n divided by a to the m, notice they're the same base again, then that's a to the n minus m. And if we have a negative exponent, you really just throw it to the other side. So if you have a negative exponent up top, you put 1 on top and you throw the exponent to the bottom and make it positive. If it was negative in the bottom, you move it to the top. But we won't worry about this one just for a second. Let's just focus on this first one, right? So why do you subtract these? So, well, it kind of makes sense, right? If we multiplied them and then we added them, so it kind of makes sense that when we divide them, we would subtract them, right? That kind of goes toe and toe. And to see how that works, if we have x to the 7th, which means x times itself 7 times, and we have x to the 4th, which means x times itself 4 times, if we divided that, well, that x would cancel, and that x would cancel, and that x would cancel, and that x would cancel, that x would cancel, and that x would cancel, and then that x would cancel, and that x would cancel. And really what we'd be left with down here is a 1, but anything divided by 1 is just itself. And what we have up here, we still have 3 x's left, right? X times x, which is x cubed. So it makes kind of sense when you cancel them out like that, why you subtract, right? And so maybe I don't really like to think like, oh, I'm subtracting. I just like to think if I have 7 x's up here and I have 4 x's up here, that means all 4 of those x's are going to cancel. And if I have 7 of those x's and I cancel 4 of them, I'm going to have 3 left. That's how I like to think about it. And I think that helps when we have to kind of use our second rule here with negative exponents. I think it helps to just not confuse ourselves if we think about it as the way I just mentioned, right? So now we have a lower number on top, right? X cubed over x to the 8th. Those 3 will cancel with 3 down here, but we're still left with 5 down here, right? And so when you think about it that way, if you think, okay, 3 cancel with 3 there, and then there's going to be 5 left in the bottom. There's still a 1 left up here. So that's really important to notice. There's still a 1 left up there. And then from there, you can jump straight to, oh, that's 1 over x to the 5th. But if you want, you can do the subtraction rule. You would say, well, that's 3, since 3 is on top and 8's there. That's 3 minus 8, which is x to the negative 5th, which then would be putting x to the 5th just at the bottom, right, with sticking a 1 on top. And let's just go through a few examples of these. So again, with these, you can just do these numbers first. 18 divided by 6 is 3, and that 3 is going to go up top, right, because the bigger number is up top. And now, what I like to think here is, right, let's think we have an invisible 1 here. You could do the minus rule, but what I like to think is I have a 1x here that's going to cancel with 1x there. And so that 4 is going to change to a 3. I can't really draw it, but that x, that's going to change to a 3. And then here, I could do the minus rule, or I could just jump straight to it, and I'm going to say, okay, 3 y's here are going to cancel with 3 y's here, and we're just going to be left with 1, right? If we have 4 y's and we take away 3, we're going to be left with 1. So what we really have, and if we canceled those and there was a 3 on top, I know it's kind of a jumbled mess, we'd have that 3, then the x's are gone on top, we still have a y, and then on the bottom, we have this x to the 3rd. And that's going to be our final answer for that one. Now, again, let's do an example here where I can do 5 divided by 15 right away. And when I do that, there's going to be a 1 left up here, but 1 times anything is just itself. So really I can just put this 3, but now it's in the bottom, right? And similarly, I'm looking which one has a bigger number here. I see 3x's here. Those are going to cancel with 3x's up here, so there's going to be 5x's left up here if there was 8. And then here, don't freak out if it's y cubed and y cubed. Those are just going to cancel each other out, right? Y cubed divided by y cubed is just going to be 1, but 1 times anything is itself. So now what's left over, we have x to the 5th on top. Nothing else, right? That 5 canceled and that y cubed canceled. And now on the bottom, we still have that 3 and nothing else, right? That y cubed canceled and that x cubed canceled. So it's just x to the 5th over 3. Now, our last example here, we have, again, I'm just going to do the numbers first. You can do 4 and 16. 4 divided by 16, that's going to leave a 4 in the bottom, right? Because 16 is 4 times 4, so 1 4 would cancel. And that's just simplifying fractions, which we should be somewhat okay with. And now, so there's a 4 on the bottom. Now, this x is going to cancel with one of those x's and just leave 1, right? So we're going to have an x down here. And then 3 of those y's are going to cancel with 3 of those y's. So since there was 6, there's going to be 3 left. So we're going to have y to the 3rd left. But now, notice everything on top is gone, but what goes on top, right? Because we've canceled, but canceling when we're talking dividing, right? Really, there's a 1 left up here because y cubed divided by y cubed, something divided by itself is 1, right? And same thing goes for the x and the 4. So really, there's a bunch of 1's left. 1 times 1 times 1 is just 1. So very important distinction that if you have nothing left on top, you still have a 1 up there. And that is going to wrap it up for the review of some laws of exponents.